Hello guys, welcome to the channel. Today we will discuss FP growth algorithm. In our previous video, we discussed a priori algorithm. If you have not watched that video, please watch that a priori algorithm because initial steps are same for FP algorithm, FP growth algorithm as a priori algorithm. So I will not like do practically from scratch for FP growth algorithm. So please watch that a priori algorithm video first. Okay. Then come to this video. So FP growth algorithm is a frequent item set mining algorithm. Okay. Used in association rule learning. Its main purpose is to find items that are frequently bought or used together. If you will find same thing I have did through a priori algorithm. Okay. So basically it also does the same thing. Okay. So suppose we have these transactions like transaction 1 bread milk, transaction 2 bread diaper eggs, transaction 3 milk diaper cola. Okay. So these are transactions and these items were bought by the customer. Okay. So so basically FP group helps us find patterns such as the customer is buying bread, he is buying milk also. If someone is buying bread milk, then they are buying diaper also. So these patterns which we can find by FP growth algorithm. So basically, you will find that we are doing the same thing by FP growth algorithm, what we have did by a priori algorithm, but there is a difference. Why FP algorithm was introduced? So the previous algorithm a priori had a major drawback. Okay, it generates a huge number of candidate item sets, right? So when you will work with larger data sets, then it will consume by a priori algorithm. It will consume more memory uses and more database scans and slower execution. So to counter this problem, FP growth algorithm was introduced. Okay. So FP growth algorithm solves this problem by no candidate generation, fewer database scans, and faster execution. Okay, that is the difference between a priori and FP growth. So main idea behind FP growth algorithm, instead of generating candidate item sets like a priori, FP growth stores transactions in a special tree structure, okay, called FP tree, frequent pattern tree. Okay, the tree compresses the data set while preserving important information. That is the this is your important information. Okay, so let's see how we can perform FP growth algorithm practically. So again, for performing FP growth algorithm, I am using the same dataset which I have used in a priori algorithm. So this is my dataset. I have already discussed about this dataset. Okay. Basically, I have 20 items. Customer one is buying these three items. Customer two is buying this one item. Customer three is buying these two items. So that is how this data set is prepared. Okay. So I will use this data set for FP growth algorithm. So what I will do is I will copy the initial steps of a priori algorithm in our FP growth algorithm because initial steps are the same. So I will copy initial steps for a priori for from a priori algorithm to FP growth algorithm. These steps I have already discussed in a priori algorithm, right? So if you have not watched that a priori algorithm video, please watch the video. I have explained all the steps here. I have explained all the steps. Initial steps I will copy from a priori algorithm. Okay. And at the last I will basically perform FP growth algorithm. Okay. So I will copy paste from initial steps. Okay. So my data set gets loaded. So data dot save. is will be same because we are using the same data set. These steps I have already discussed. Okay, these steps I have already discussed. You can watch my previous video of a priori algorithm. Okay, then come to this video because initial steps are same. So that's why I'm not explaining the initial steps. I've already explained these steps. So initial steps are very same. Okay, I have created a market list where I have string values. I will store those values into the market. Okay, then I imported collections to see basically the all the items, how many times they are getting purchased, how many times they are getting purchased. Okay, for example, mineral water is purchased 1,787 times. Eggs were purchased 1,348 times. Okay, so that's what it is telling me. Now I will store this into a variable. I will see the my all the categories, my all the products. Okay, I will see their values, how many times they were purchased. I've explained all these steps. You can watch my previous video of a priori algorithm. Then then I have stored in a new variable of these keys and these values uh, in a new variable. Okay. Then I transform this into a data frame. Sorry. Now next I converted this table into true false table. Items are getting purchased, that is true. Items are not getting purchased, that are false. Okay. These steps I have already explained. So yeah, this is a warning. This is not an error. You can ignore this. Then I have stored this into a new variable, new df. Now you can see the table, true false table basically. Okay. Then in the last step, in previous video I have applied a priori algorithm. In this video I will basically take FP growth algorithm. Okay, so from mlxtend dot frequent patterns import FP growth. Okay, now I will take FP growth. So if I will click shift plus tab, then these are their hyperparameter. First, df means take your data. So my data is new df, new slash df. So this is my data. Again, shift plus tab, minimum support. Suppose I will take minimum support. 0.5 means here it is taking 50%. But minimum support here default value is 50%. But I will not take 50%. I will take 5%, 0.05. This is 5% and 0.5 means 50%. So if I am taking minimum support is equal to 0.05, what it means? So we are saying that item set will be considered frequent only. Like we are saying that by taking minimum support 0.05, set will be considered frequent only if it appears at least 5% of all the transactions happening. Okay, that's what I'm saying by minimum support is equal to 0.05. Now let's check other parameters. Other parameters use column names is equal to false. It is the default value. But I will do true. I want the column names. Okay. Now again shift plus tab. Max length is none. Let's take max length is 3. Let's take as 3. So what is the meaning of max length and why we are taking 3? So what it means? I am saying that the maximum size of item sets to generate basically 3 item sets. So suppose 3 item sets are purchased together, bread, egg, and milk. Then it will show me. Suppose one item set is purchased, that will be shown. If 2 items are purchased, milk and bread, that it will show. But if 4 items are purchased together, it will not show me because I have put a condition of max length is equal to 3. Means only three products which are getting purchased at a single time, that products show me. Please show me the those products which are getting purchased at a single time. So it will show me one, two, three. One product purchased, it will show me. Second, two product purchased together, it will show me. Three products are getting purchased, it will show me. But 4 products which are getting purchased together, it will not show me. Okay, you can basically customize your values. You can take 4, 5, 6, whatever value you want. Okay, I'm taking it as 3 now. Now you can see that. Eggs are getting purchased frequently. Okay. Burgers, turkey, mineral water. Okay. So these values we got. See, mineral water and eggs. Suppose I will sort the value by descending. Sort values by which we will sort by support. Okay. Now it is saying soup is getting purchased frequently. Mineral water and eggs are getting purchased frequently. Okay. Mineral water and spaghetti is getting purchased multiple times together. Okay. That is what we can find by FP growth algorithm and also a priori algorithm. Okay. These two algorithms which comes under association rule learning. Okay. So this is what FP growth algorithm does. Okay. So that's all in this video. In the next video, we will discuss ensemble learning. Okay. Thank you.